Alright, so this is section 10.11, which is on tests for variances of normal populations. So we have to assume our sample comes from normal populations to do these tests. So let's say x1 all the way to xn is a sample from a normal population. Population mean is mu, population variance is sigma square. And S sub x is the sample standard deviation. Now suppose we want to do a hypothesis test with no hypothesis is the population variance is equal to a number. Then our test statistic is called chi-square. It's defined by n-1 times sx squared over sigma 0 squared. So this is our test statistic, and after we get this number, we look at the chi-square table. And the degree of freedom in this case is n-1. Okay. So let's do an example. So let's get a chi-square table out. That's here. Okay. Okay, so let's do an example. So let's suppose our sample size is 26 and our sample standard deviation is 0.8. Then we can consider the hypothesis test. We want to show that the population standard deviation is less than 1.2 because 0.8 is less than 1.2. But we usually don't phrase it this way because we want to talk about variances. So we put the square on both numbers. So this is our alternate hypothesis, and the null hypothesis is the opposite of the alternate hypothesis. Okay. So our test statistic chi-square is equal to n-1 times s squared over 1.2 squared. So if we put everything into the calculator, this is equal to 25 times 0.8 squared over 1.2 squared. This is equal to 11.11111. It does not stop. And the degree of freedom is 26 minus 1 is 25. So we look at the row 25 and we look at the number 11.111, which is between these two numbers. So these two numbers are the one we're focusing on, but be careful, these are not the p-values because 0.99 means area to the right is equal to 0.99. But that's not the area we want because we want the area of the tail. So instead, the area we want is the one to the left. So area of the tail is equal to 1 minus 0.99, which is 0.01. And then same with the other number. So the p-value is between 1 minus 0.99 and 1 minus 0.995. So p is between 0.01 and 0.005. In any case, because p is less than 0.05, that means we can reject h naught at 5% level and conclude that sigma square is less than 1.2 square, or we can conclude sigma is less than 1.2. Alright, so let's do an example of the two-sided test. So let's move the table over. Let's erase all these. Okay, so let's do an example of two-sided test. Okay, so let's suppose our sample size is 16 and our sample standard deviation is 1.3. We want to show that the population standard deviation is not equal to 1, or population variance not equal to 1. And so the null hypothesis is the opposite, which says the population variance is equal to 1. So the test statistic chi-square is equal to n-1 times s squared over 1. I guess technically 1 squared, but doesn't really matter. 1 squared. And this is 16 minus 1 times 1.3 squared over 1 squared, which is 25.35. And the degree of freedom is 16 minus 1, which is 15. So if we look at the row 15, and we look for the number 25.35, that's between these two numbers. So these two values are the one we want. But notice that this is two-sided test. So P is between these two numbers times 2. So that means P is between 0.1 and 0.05. So because P is not less than 0.05, we cannot reject H naught at 5% level. So we can't conclude anything. Conclude anything.